Hello everyone, this is one of the questions we're going to be doing today. It's an electricity question. It's quite simple if you think about it. I'm going to let you pause the video and attempt it yourself. Okay, back. So, in order to solve this question, we're going to treat this entire system as just two resistors. This is our first resistors, the resistance of R, and this entire system of resistors we're going to treat as only one resistor. This entire system of parallel resistance we're going to treat as one resistance. So to think about this, we know that in parallel circuits, the total resistance is always less than the minimum resistance, like the minimum resistance of one of the components. So because all the resistances here are have a resistance of R, we know that this entire system is going to have a resistance that is less than R. We know that all of this is less than R. So all of this is going to be less than R. So what does that mean? That means that also as we increase N, so as we add more and more resistors, we're gonna add more and more resistance to the circuit. However, it will never reach R. It will always be less than R. So we know that as N tends to infinity, the resistance is always increasing, but it is always less than R. What does that mean? That means that all of this, and infinitely, it approximates R. So in that case, the entire resistance, because we have two resistors in series, we can just add them up. So in that case, we have R from this resistor, and then we have R from this entire thing plus R. So we know that the total resistance of this entire circuit as n tends to infinity is going to be equal to 2R. Let's test this theory because we didn't do any mathematics here, we didn't do any math, we just saw about it about in physics terms. So if we do actual calculations, let's say n equals 2. In that case, we know that this is going to be R over 2. So we have R over 2. This is less than R. The total resistance would be 3R over 2. We say that's not equal to 2 because n is very small. We need large values of n to actually get there. Let's test n equals 3. N equals 3, that means this is equal to R over 2. This is equal to R over 2. Then because this and this are in series, we add them up. We have 3R over 2. It's the same for here, 3R over 2. So all of this entire thing, is equal to 3R over 4. You see, as n increases, we approximate R less. So this verifies our theory that this, as n tends to infinity, the resistance of this, so Rn, also tends to 2R. However, we want an actual equation for this, an actual expression, so we can calculate the resistance, so we can calculate Rn for any value of n. So to do that, we're going to have the following. We can treat this as sets of parallel circuits. So what we do is that we group them like this. So we have one set of parallel resistors with two parallel resistors. Here we would have 4 parallel resistors. Here we would have 8 parallel resistors. So what does that mean? That means that this is equal to R over 2, this is equal to R over 4, and this is equal to R over 8. So that's what we have. And this, for example, if we had an n equals 5, it'd be R over 16. And you have to add them up because the way we treat them, these are all circuits, are all resistors in a series circuit. So what do? We just have to add them up, but you say this goes infinitely. But you can probably spot the pattern here. The pattern is that this is a geometric sequence. It's a geometric series. So what we do is that we have A, the first term being R, we have the ratio being a half. So from this, if we use the geometric series equation, we have R brackets 1 minus a half all to the power of n all over 1 minus a half. So this is our expression. We know that the denominator is going to be a half. So we have 2R brackets 1 minus a half to the power of n. And this is equal to Rn for any value of n. So if you want to test the theory again, we know that as n tends to infinity, this is gonna become very, very, very small. It's gonna basically tend to 0. So that means you have 2r times 1, which is 2r. So yep, the mathematics agree with our physics. This is the solution. This question is really similar from the one we've done before. I'm gonna let you pause again and try solve it yourself. Okay, back. So this entire system of resistors can be redrawn as this. And as n increases, you just have more resistors here. So you have more oil. You have here, here, all of that, and then an extra resistor here, and you just follow the pattern. Cover. Let's look at it as if we had only 4, and then from that we can adapt. So as we did in the question before, you can treat these as systems of parallel circuits. So this one, and add them up later as a series. So you can treat this as one resistor. Well, this is one resistor. You can treat this as one resistor. You can treat this as another resistor, this as another resistor, and so on, and so on, and so on. And then you just add them up. So if we do that, we know that the first one has a resistance of R. We know that this one has a resistance of R2. There's 3 resistors here, so we have R over 3, we have R over 4. Then again, we have R over 3, and then we have R over 2, and then we have R. So then we would just add all those resistors up. So you have R plus R over 2 plus R over 3 plus da 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 plus R. So that's what we'd be doing. And that'd be the total resistor, Rn, let's call it. That's going to be the total resistance. As you can see here, it's not like the question we had before where it converged to one singular value. This, when we have n tends to infinity, Rn also tends to infinity. There is not one singular value like that it converges to. This actually has no conversion. It's not geometric sequence. So what we do is that we're gonna find out an equation, an expression to calculate R depending on n. I'm sure you can already see the pattern here. The pattern is that we would have this. We have the sum, n equals 1. We have, and then this, just n equals, no, not n, it's R, sorry. R equals 1, and R equals n. Of 1 over R, so you see this is 1, this is 2, this is 3, this is 4. And you say, but there is 2. So we have 2 here. And then what we do is that because from this one is R equals n, because n equals 4 in this case. So we have is that we only have one set of this, but we have 2 sets of the rest. So we accounted for 2 here, but to account for this, we're just going to have to take away 1 over n. So this is what we do. This expression gives us the value of Rn. This is the last question we're going to be doing. I'm going to let you pause again and try to do the question yourself. Okay. So this question is fairly simple once you have a diagram drawn. If you try to solve it with just this, and try to visualize where the current is going and how the resistance is going to work, it's going to be really, really hard for you to visualize it. But if you have a 2D diagram, it becomes fairly simple. So we'll start at A. We can see that the current has 3 paths. It has 3 places to travel, each with 1 resistor. So we have this. So now we're here, here, and here. As you can see, you can't go backwards, but you have 2 new ways of going for each of them. 2 new ways. So we have that is split into 2. Okay. So now we know that they actually, instead of splitting, this time they merge at one point and there's only 1 resistor to go. So it goes from there to like just one way. So in theory, and it is the same for all of them, here you only have 1 way to go, here you only have 1 way to go, and the currents are merging at this point. In theory, it should be like this, and this one are actually connected. However, I have no way to actually draw this in the diagram, so we're gonna just draw it like this, because essentially it's the same thing. It gets you the same thing, so it doesn't really matter. And now we know that they all merge at B. B. Let's say. Okay, so now how we did for the previous questions, we can treat this as sets of parallel resistors. We know that this is going to be R over 3. This is going to be R over 6. This is going to be R over 3. So once we add them all up, we get 2R over 3 plus R over 6. So that's going to be 5R over 6. And this would be our final answer. An easy question. All the entire difficulty of this question is about drawing the diagram. You have to know how to draw a diagram. Once you draw the diagram, it becomes amazingly simple.